Here's an example of a question where it would be handy to use point-slope form. So let's take a moment to read it. You need to pause it. And now that you've read it, let's look at how we can find the equation of it. So it might help to think of this as to look at what's given, to make a little table maybe. So we're given x coordinates and we're given c coordinates. So let's see, the cost was $9,000 to make 50 touring bikes. So 50 touring bikes is the number of bikes made. So that means x equals 50 there. And the cost there, that's what c is, the production cost, is 9,000. And then it takes, to make 125 bikes, that's going to be a cost of 15,000. Always helps to keep track of the units of the numbers you have. So to find a linear equation, we're going to use point-slope form, which normally we write in this format, where we say y minus y1 equals the slope m times x minus x1, where x1, y1 is any one of these points. In this case, instead of y, we're talking about c. So, leave that one alone. So we're going to talk about c1, and you can use this point here, would be as good as any to plug in. Instead of actually y, we should be talking about that as c. So let's plug this in to the equation. Oh, but wait, we don't know what m is, so we're going to have to find that. The x minus x1, that's going to be that 50 there. Right, so we don't actually know the slope, so we can't really finish this yet. So let's find what the slope is on the side. To do the slope, we're going to get the change in c divided by the change in x. The change in c is going to be 15,000 minus 9,000 divided by the change in x is 125 minus 50. That comes out to be 6,000 divided by 75, which is 80. And skipping ahead into the future a few seconds because I made a mistake I am recording over. So you take that number 80, the slope, replace the m here with that, and now you have this equation, which is you're almost done, but the problem is it says, there's some tricky language here. It says for the company's monthly production cost C in terms of the number of bikes made X. That means it should look like it's in the form C equals, because if it's an equation for C, you don't want to have anything else on that side with X in it somewhere there. So let's get it in that format. I'm going to start by distributing the 80 into this, like so. 80 times negative 50 should be negative 4,000. And I made a mistake there. I should still have the same thing on the left side. But now let's actually add that to both sides, because the goal is to get the c by itself, which gives you the result c equals 80x plus 5,000. Now that is an equation for c in terms of x. That is the answer to part A. Now we can state the slope and the vertical intercept of the line, including units, and see what they tell you about the problem too. So first of all, the slope is the number multiplied by x there. And what are the units of that number? Let's see. Well, we got it by doing a change in dollars over here. This was dollars, and then the 125 and the 50, those are bikes. So the slope is $80 per bike. And what that means is that is the rate that the total production cost increases when you build one more bike. So here are a couple ways you might write that out. Now, it also asks about the vertical intercept of the line. The vertical intercept is going to just be the 5,000. That's the c-intercept in this case. And that's what you get when x is 0. So the intercept is, I wrote it here, including the units, because if you include units here, that makes it a lot easier to understand what this represents. Because remember, the units of x are bikes, the units of c are dollars. So when you talk about the c-intercept, that's what you get when x is 0, which means 0 bikes and $5,000. So what does that mean? That's how much the production cost is if you produce 0 bikes. So I wrote that out as a sentence here. And another way to think of that is overhead is $5,000. That means that's what it costs to keep this factory open if you're not actually making any bikes. You have to pay the rent for the factory. You probably have to pay the health insurance for your workers, even if they're not doing any wages that month. So that's called the overhead. Now, here's one more exercise for you to do, which is similar as this, but it's good to get some practice. And good luck with that. And next up, I think there's going to be a reflection question for you to do. And I'll see you in class.